I hope you remember what the question is about. You are throwing an object vertically upwards, first holding it 8 meters above the ground. So it's going in a straight line and it's moving at a constant acceleration. Let's see whether this is true. I'm telling you that it's moving at a constant acceleration. I don't know whether you realize that going up, it's decelerating, coming down, it's accelerating. Going up, it's slowing down to 0, and dropping down back, it accelerates. So it's a deceleration and an acceleration. Do we say it's constant? Is it constant? Is it the same? So let's see, okay? Now the first part we did, right? So the things to remember in these questions where you apply equations of motion is that you have to always say from where to where you're applying your equations of motion, because a lot of the times you might not be applying them to the whole motion. Now the whole motion for this object is, it starts here, that's where it ends. That's the whole motion. But for example, to answer this part, you can't apply to the whole motion. You have to apply to part of the motion until to the maximum height. So you have to break down your motion into parts. If you use labeling, if you call the starting point A, this point B and C, you can easily say, so for the first part, you apply from A to B. This has to be there. Whenever you are applying equations of motion, you have to say to which section of the motion you are applying them. So that your initial, your final velocities would be to that part. Okay? And the second thing you have to write is what? Two things you have to always say whenever you apply. The direction. Which direction you are taking as positive. So we usually take the direction of the motion. Now from A to B, it's going up. Let's take upward as positive, and you are measuring your displacement from the starting point. Your reference point is here. Nathan, if you listen, it would be a lot better. So from here, right? So this is where you start, like if you are measuring the distance traveled by this object, you are starting to measure from that point. After you have done that, you write what you know for that section. So you know U is, we did this last week. You know U is 50, you know V is, it's a hidden information. In questions like this, that the speed at the top is 0. They won't say it, you know it. At the maximum point, it stops momentarily to come back down. So V is 0. At B, velocity is 0. So U, B, we know A. Upwards, it's minus 10. We take acceleration of gravity to be 10. Why is it minus? Because it's decelerating. It's a negative acceleration. Okay, it's 10, but minus 10. It's slowing down 10 by 10 every second. Okay, we discussed this last week, and we are finding we want distance. We want s. So you always have to write this. There should be 3 information, and you're finding 1, and then you choose which equation that fits for this information. So just B squared, right? We did that, and you get S is equal to 125. You got this last week. Now part B, time taken to reach the maximum height. Again, you have to apply equations of motion to which section in order to answer this. A to B. Time taken to reach the maximum height. That means time taken from A to B. Is that clear? So you have to say A to B. Let's say that A to B. And you are applying it in upward direction. Now let's write our set of information again. Now you have so many. Now assuming that we haven't found this. Now independent of part A, we will do part B. Independent of part B. As if you are just doing this part for this question. Nathan, are you listening? So we are only just for this scenario, we want to find how long it takes from A to B. So what do we know? We know U is 50. We know V is 0. We know A is minus 10. We want to find D. 3 known information and what you are finding. And then you choose. So for this, it is what? V equals U plus A. And can you plug in the values and find it?
Yes, I did.
Time is 5 seconds. Right, so I will not show the word. We get T is 5 seconds. And notice that I did not write the units when I was writing the list of information. You don't have to. If they are consistent units, all standard units for distance, meters, for time, seconds, for speeds, meters per second, for accelerations, all meters per second square, then you are using consistent units. Then you don't have to show it here. In the final answer, you show the unit. Okay? 5 seconds. And then again, part C, let's do it independent of the other two parts. Let's see, just they have asked, find the total distance traveled. Okay? This is the picture scenario, what happens, the story. Find the total distance traveled by this object. So to which section of the motion do you have to apply the equations?
A, B and BC. A and BC.
So Nathan is saying A to B separately and then B to C separately. Atri? A to B separately and B to A to C separately. Why is that? If we can't we do A to C straight away? We want this total distance traveled. So total distance traveled, A to B to C. So can't we do A to C straight away? If you do A, we want distance traveled, that means we want the distance it traveled, right? It traveled there. From A to C, what's the displacement?
8.
You already know it's if I had asked, what's the total displacement of this object? It's 8, there's nothing to do with 8. Started at A, ended at C, it has displaced by 8 meters. And remember your S in your equations of motion is displacement. If you apply an equation from A to C to find S, you would get 8. And you don't have to apply equations for that, you know it already. What we want is the distance traveled. So you have to break this down. You have to do A to B, and then B to C, and then add them. Because if you do from A to C straight away, the displacement, if I had not given this, you would get that only, not the travel distance. Is this clear? Okay. Now, since we have already found A to B, so you would, if this had come in as an independent question, you have to do that first, and then from B to C, and then add. So since we have done this, we will only do B to C. B to C in what direction? You do in the, you have both options. You can do upward or you can do downward. Let's always apply up in the upward direction.
Yes.
Yeah.
Now since you know A to B as 125, so again from B to A.
Yeah. Yes.
And you can plus.
Yes, very good. Right? Very good method. After finding this, actually, this is true for any motion under gravity. Because as I said last week, motion under gravity is symmetric. Like if you go, it's symmetric that the upward motion and the downward motion, they are symmetric. Now what that means is that at any level, going up speed and the going down, coming down speed are the same at any level if you compare them. And if I had thrown this away from the ground itself, from here itself, if it goes up 10 meters, it will come back 10 meters. It's 10 up, 10 down. Here, if you start at 8 meters above, this is 125, then up to here 125, and another 8. Right? Once this has been worked out, it's just 125 plus 125 plus 8. But just for the sake of doing this, okay? You don't have to do this. Just for the sake of, because you are applying for the downward motion now, I just want to discuss that. You would get that. Here also you are getting that. Like if you didn't realize that you can do it like that, say you want to find the distance traveled from B to C. Suppose we didn't know any of this, you want to find the distance traveled from B to C. Say you are dropping this from point B. It could be the same thing. If you drop, you hold it here, you hold the object here and drop. Drop means, the word drop means your starting velocity is 0. You can throw something down or you can just drop it. Drop means U is 0, right, at that point. Okay? So, like suppose you dropped it at B and you want to find how far it traveled. So, if you apply from B to C, do we have enough information? Just for the sake of, like, you don't have to do, first show you can just do it. 125, the total distance is 125. So 125 plus 125 plus 8. That is?
That is 258.
258. If you were to apply from B to C, Malik, B to C, do we have enough information to find S? We do. And which direction are you going to apply? Yeah, you can either apply downwards or upwards. Is there a difference? There is a difference. In the signs, there would be a difference in these quantities. Again, as a convention, we always apply upwards. Okay, but if you want downwards, we'll do downwards. Okay, downwards. So if you do downwards, U is 0. What is going on? A is downwards, it's moving down, direction-wise positive, and it's accelerating, so it's just 10, plus 10. I want to find S. I need one more information. Do I have any more information?
120 upwards.
From B to C, S is what I'm trying to find.
Yeah, S is what I'm trying to find. Then you have.
If this was a question about an object that had been dropped, that information is not enough to find how far it has traveled. Because you don't, so S question mark, but I need one more information. Do I know the time? What are the 5 things? U, V, A, S, T. U is there. Do I know the final velocity here when it hits the ground? I don't know that. Do I know the time? I don't know that. So here it's not enough information anyway. Okay. All right. Last part. The speed of the object when it hits the ground. Now this is a story. Find the speed when it hits the ground. Again, independent of all other parts. Let's just work this out. If you are given this story and asked to find the speed with which the object hits the ground, the velocity at C. To what section do you apply? A to B to C? B to C. If you do B to C, let's try it. If you do B to C, now independent of this, you don't know this, you don't have this, you're just working this out. If you do B to C, then downwards, U is 0. In the end, we want to find B. What else do we know? A is 10.
Then we know that for the displacement at B to C,
we know
S equals 100.
B to C?
Yeah, B to C.
Independent of this. We are just doing this.
So we don't know the distance yet.
Do we have the time? Do we have do we have S from B to C? No.
No.
Do we have the time from B to C? No. These are the only things we have. The best is to apply from A to C, because if you take A, you know the displacement from A to C, it's 8. That additional information becomes, the information that we lacked here, we don't know S from B to C, but we know S from A to C. Let's apply from A to C. But can you do that? Or from A to C straight away, because it's an up and down. No, independent. No, listening now, independent of this.
So we know U.
Which direction would you apply? Upward. It started going up. Then think and now tell me, what is U?
U equals 50.
U is 50 and positive 50. What is A? Think and tell me.
Minus 10.
Is that minus 10 both up and down?
No.
Yeah.
Okay, going up, it's going up, direction is positive, so it's positive, but it's decelerating, so you put minus 10. Coming down, it's accelerating, so it's 10, but it's coming in the other direction, so it is minus 10 again. Do you see from A to B, A is minus 10. Do you understand that? If you take this direction as positive. From B to C, if you still take that direction as positive, same direction, A is still minus 10. So it's minus 10 throughout. Here, this minus came because of? Not the direction, because of the retardation, deceleration. It's a negative acceleration. Here the minus is because? Yeah, it's coming down, B to C is coming down. We have taken going up as positive, then coming down must be taken as negative. That's negative. But it's accelerating, so positive acceleration. This negative is due to the direction. Negative direction. This negative is due to deceleration. However, it's minus 10. So from A all the way to C, throughout, it's minus 10. It's constant. That's why it's constant. Even though it's in one direction it's deceleration, other direction is acceleration. When you apply upwards, A is minus 10 regardless of whether you're going up or down. Minus is minus 10. If you like need that, write it down on the side. What else we have? For the whole thing, we have S. S is 8. That's enough. We need only 3. What we want to find? D we want to find. Right? Quickly find it. What's the equation? V squared equals U squared plus 2S. C is 51.58. Just a second. Okay, Mihir? Now you are okay. So earlier you were not okay. Okay. Now in the exam, you don't get a separate one whole question from this little topic equations of motion. You get to apply equations of motion in a different big question as a part. Okay. So when we start discussing exam questions, you will see that. So I'm not going to let's do one more example. And then we'll talk about graphs. Okay? Not example, exercise. So one exercise for you to do. Can I raise the board? Okay, exercise. This is wrong. So which one is right? Is this the equation you used?
I used that equation from B to C. I used my method now cutting downwards. I done it earlier.
You need B to C.
B to C.
You have U is 0.
B 0.
A, did you take up or down?
Down.
Down. So A is 10, B question mark, and what else you use?
Actually, S, no S.
S is not this.
Yeah, I know. It is
125 plus 8. Oh yes, it should be the same.
We got
What's 125 plus 8? 133. And you would use the same equation. Here you get u square is 50 squared minus 2 times 10 times 8. Here you get u square is 0 plus 10 times, what was your answer? 48.37. How you got it?
Together they have to take that. But if you put it and separate because we are minus it. We are different.
Separate figures mean we are finding the velocity now? Yeah.
Let's say you take 50 square and then you minus it from 160. Then you do the answer you will get 41.5.
So this is that minus 160. Yeah, so what I'm saying, if you do this, so what if you do, what did you get, Marit?
I got 48.
This, okay, 2500 minus 160, 2340, and square root of that. 48 is what you get. So you get, what did you get?
So what is first? Okay, that is 2 into 10 into 133. Then that is 260, 2660. 2660.
You get?
2660.
Yeah, you get 51.57. Yeah, there is something wrong here. So you get something. B, you get 50. Let's see what that is.
Could it be the fact that since it's going 1 to 1, could the thing is 115? Now at the same level, maybe like it of the same level from A, it's from A to B and B to A. So at the same level, it will be the same. If 50 will be less, and maybe it will go down. Due to acceleration, by accelerate, it's accelerating.
So, okay, can you find the mistake? Minus. No, the plus.
Yeah, as a thing, it has added 100 axis. It should be minus 100 axis. We have a correct answer.
He used, that is when you get 51.
Yeah, it was also 500 plus 100.
Yeah, that's when you get 50. I got it.
Yeah, when you apply this, that is what you get, the 2660. How is that? That's what we want to figure out, 2060. What mistake is there? Just my diagram. Something wrong. I can't see it. Can you see? That's the mistake. Do you understand what's happening here? So we applied it from the starting point A up to C. He is doing from B to C. We from A to C, he is from B to C. This can't go wrong. So where have you made? I can't spot it.
Because I think it's somewhere related to the distribution.
Huh? But this is right now?
It's the formula. So you use this V square plus. What's the formula you use?
It's the same formula. This can't happen.
Miss, why don't you try using the equation s equals ut plus half a square?
We don't have the time. You can understand it in a different way. We have the time to do it, but we don't have so if you spot the money, are you making an effort here?
I'm trying to figure out why.
Yeah, okay, you are trying to.
Now, we took only 8 meters. Like,
Yeah.
this I want we take 125 plus.
No,
S is displacement. So from point A to C, the displacement is 8. Displacement.
Yes.
Okay, I'll tell you, so we'll leave that out. We have to come back to it. So if you can figure out what the mistake we've done, huh? I can't see it now. Let's come back to it later and look at it with fresh eyes later. We'll see it. Exercise.
Then we told that at any point of the equation, if it is going up.
Yeah, same speed.
Same at the same speed.
Yeah.
But that thing over there is 40.
Yeah, this is less now.
It's less, but that.
I saw it. No, yeah, that I spotted the mistake. It's here. Okay, so you what? Sign of what? No, sign of acceleration is correct there. Upwards.
no, it's negative.
What is negative?
Say A.
A is negative.
No, I mean that.
Halfway. So that minus are put here. Come on.
Is it supposed
But we say we put down acceleration is plus.
No, we're taking up.
Miss.
I'm applying it upwards. So that's why my 50 is positive. Yeah. So
minus 10 plus 10.
I explained it here. If you are taking up in the upward direction, throughout the acceleration is minus 10. Going up minus 10, coming down minus 10. Yes, who said that? S negative. S negative. You're starting from here. You have ended up negative 8. This is, I put that in red. So this becomes plus. Yeah, otherwise you can never make different answers like that. So it's 51.5. 51.5. Now put a star there. Put a star there. Yeah, okay, let's discuss that. If you had taken, done? Okay, if we had taken downwards A to C, if we had taken A to C and applied the equations downwards, now tell me each of the information again from the beginning. What would be your U? Pick and tell me. If you are putting downwards, minus 50. Everyone understand that? A is
Positive.
plus 10. S is positive 8. And B question mark. Let's get the answer. Okay? So this is very important. Everything, all these is with respect to the direction you have taken. What direction you have taken as positive. This plus minus signs all apply to the information that you are writing here relative to the direction you are taking. If you say how the signs are different, but the final answer will be the same. And here, good for the velocity, yeah, you will get a positive answer, it's going down. You get a positive answer, it's going down. Here, what do you get? Here you have to get, you get when you square it, you get two answers. You actually have to take the negative answer. Yeah, that's okay because you know it's coming down. You have taken upward, your answer is supposed to be here, negative 51, which means it's going down 51.5. Okay? That's it. Okay. Let's do one question as an exercise and then we'll start.
That negative sign just change that.
We'll do graphs. And then once we have completed this motion in a straight line section, we'll start exam type questions. Okay? So one exercise for you. Quickly write. A car is traveling at a velocity of 20 meters per second. A car is traveling at a velocity of 20 meters per second. When the driver sees,
This is an example.
this is exercise.
20 meters per second.
When the driver sees the traffic lights ahead, change to red. He decelerates at a constant rate of 4 meters per second squared. He decelerates at a constant rate of 4 meters per second squared. Meters per second squared and comes to a stop at the lights. And comes to a stop at the lights.
Right.
At the lights.
Right.
Yeah, maybe. At the lights. Find how far away from the lights. Find how far away from the lights. No, just one question. Find how far away from the lights the driver started braking. Find how far away from the lights the driver started braking.
The moment he hits the brake, right?
That means from the point he starts to decelerate.
Is the constant rate plus 4. In the middle of the equation.
Yeah. So it was, he was moving at 20 meters per second when he started to apply brakes and yeah, initially.
Which is the position from
Yeah.
Why do you ask that? Is there any other like because you want to find? Yeah, it's important. From the moment he applies brakes, starts to decelerate.
Miss Jayakody. I.
Okay. One more. A is Rachel, 4. Madara, 4. Johan, what's A? According to how I have it. What's my A? I'm applying in this direction, in the direction of its motion. 4. Bimandi. Kavindi. I think I'm saying names. Kavindi. -4. 10. -10. Mihir. -4. Hatvi. No, before -4. Bimandi. -4. Malit. -4. From where did the 10 come? Is the car falling down or something? No, but where do you have a 10? I can't. Just lower it and alter. You took A as gravitational acceleration. Like the okay. What do you think now? You have different answers. 4, -4. It's decelerating. So it's a negative acceleration. It's -4. If you make that mistake, everything is wrong. -4. If you put 4, you would be taking that it is speeding up as it is speeding up. Your V is 0. It stops, and you have to find S. And have you all indicated the direction in which you are applying them? Now, see, all my words have gone down the drain then. You don't listen. You have to say from where to where you are applying and in what direction. Now, in this question, of course, A to B, you don't have to say because it's the whole motion. I'm just because I drew a diagram, I'm saying it. But if you are applying it to the whole motion, you can drop that. That means you are applying it to the whole from the beginning to the end of the motion. But this always has to be there, like in one direction. Like you have to show a direction and right.
Yes, the question means that the car stops again at the traffic light.
At the traffic line.
But if it stopped, this question will mean that it could have stopped before that line was.
Could be.
Then
And they can ask how far it traveled before stopping. Now here they are asking how far away from the traffic light, because we know it's stopped at traffic lights. The wording is different.
So, I mean, I thought that was could be.
Yeah, so if it stopped here, they would just ask how far it traveled. So S is how much? S is 50. You wouldn't get that if you put plus 4 there. Okay. Let's start the next topic. This is parallel to equations of motion graphs. And this is something that you have learned before. So I'm hoping that we can just do it a bit faster. Motion graphs, and we are learning two types of graphs. What are the common two types of motion graphs that you learn? Displacement time and velocity time. So we'll start with displacement time. Displacement time graphs. Displacement time graphs. Okay, so what are motion graphs? A motion graph is when you represent the motion of an object using a graph. So the two main graphs that we use are displacement time and velocity time. So when you have displacement time graphs, so y-axis is s, the displacement, and the x-axis is time, so it's st. You can also say st graphs and bt graphs. This is st graphs. st graphs. So when you have an st graph, you are showing how the displacement of that object is changing with time. As time passes by, how the displacement of the object in concern changes. So you always have a starting point, right? And a mark there is a person starting at A. See, moving starts to move this way. And I'm going to show the motion of this man in this graph. And you have to explain to me by looking at the graph how he has moved. Has he gone at a constant speed? Is he accelerating, decelerating? Has he stopped somewhere? Okay? So I'm taking this as positive side. That's my positive side. Okay? So if the graph goes like this, just think about it. I'm starting here. So this is t equals 0. It's starting, this is where I'm starting to count time. It starts from 0 here. I will mark different sections so that you can identify. So this is A. Up to here it's like a curve. And then from B to C it's a straight line. From C to D it's a curve again. From D to E it's a flat straight line, like horizontal straight line, a slant straight line. And then say
dots.
that here.
Yeah. Not like dots in the exact.
Right, yeah, sure. Yes. Understood. Yeah. That?
Yeah.
Yeah. And then a curve like this. I'm just trying to cover all different types. So we have a straight line. Up to here, there is a curvature. From here it starts, it's a straight line. And then from here, CDE, G, H. Now, you put your hand if you know the type of motion that I'm asking for each section. From A to B, can you identify how he has moved? So you have to explain like constant speed, he's moving at constant speed, he's accelerating, he's decelerating, like how he is moving. You have to know that if your S is changing, he's moving. A to B is moving, B to C is moving. I'm asking how is he moving? What is the type of motion? Constant speed, acceleration. These are the three options. That's all you have. Constant speed, deceleration, acceleration. Out of these three, what's happening from A to B here? Acceleration. Agree with everyone? How do you know?
Because I told as
Yes.
The gradient of the graph is increasing. The gradient represents the velocity.
Ah. So that's the most important thing that you have to know about displacement time graphs. In a displacement time graph, the slope of your graph, the gradient of your graph tells you the velocity. So if I want to know the velocity of the object right at this point in time, if I want to find what the velocity is, I would have to find the slope at that point. So I think of the tangent and what's the slope. And if you study how the slope is changing from A to B, first it's like that, and then the slope is increasing. So first just say to yourself what's happening to the slope, and then replace the word slope with velocity. Then you would know how it's moving. So here, slope is increasing, that means velocity is increasing, that means acceleration. From B to C, the slope is the same, constant. Slope is the same, slope is constant, that means velocity is constant, constant velocity. From C to D, slope is decreasing, velocity is decreasing, deceleration. D to E, zero slope, no slope. His displacement is not changing, it stopped, stationary. E to F.
Accelerating.
E to F, what's happening? What can you, first of all, E to F, what can you say about the gradient? It's
Increasing.
It's increasing. In addition to that, what can you say? What's the difference between the gradient here and gradient here?
It's negative. It's
a negative gradient. See, look at the slope. Draw a tangent line here and see. The slope is negative. This is O-level. If you have a line this way, that's positive gradient. If you have a line that way, it's negative slope, negative gradient. A to B, the gradient was positive and increasing. C to D, the gradient was positive and was decreasing. E to F, the gradient is negative and it's increasing. What does that mean?
It's accelerating.
You're saying accelerating, right? Because the gradient is increasing, the slope is increasing. Think of this like a little mountain. If you were to like come down, here it's very steeper, this is less steep. So it's from E to F, it's getting steeper and steeper. Slope is increasing, that means velocity is increasing. So it's acceleration, you all agree? Perfect. So you said here acceleration, right? Here you said constant speed, constant velocity. Here you said deceleration. Here you are saying again acceleration. What's the difference between this acceleration and that acceleration? Not value-wise, we don't know what the value, we don't know whether it is 5 meters per second squared, 8 meters per second squared. Can we find it? Can we find the value of the acceleration, the number? What's the acceleration? We can't find it from the graph. We can't. We know it's accelerating. We can't even say, is it a constant acceleration? It's hard to say from the curve. So I'm not asking about the value, but what's the difference between this acceleration and that acceleration?
Displacement is negative. That means
Displacement is positive. You're on the positive side. All these are positive values. It's coming back.
yeah.
Or from A to B, if it was going this way, it was going that way. From E to F, It's at E, it is turning, it's turned and coming back. How do you know it's coming back? Because the displacement is reducing. Now you are starting to measure from here and you are starting to measure from here. How far you are going? Your displacement. Now you go. So your displacement is increasing. Your displacement is increasing. So your displacement is increasing. After this, your displacement is now decreasing. Then you are walking back towards the starting point. You are coming back. So this is accelerating. We can say in some direction. Constant speed in that same direction. Deceleration in that same direction. This is accelerating in the opposite direction, whichever the direction this was, this is in the opposite direction. Coming back, you can just say coming back, returning, coming back. F to G, coming back at constant speed, G to H, coming back at the retardation, finally, looks like stopping this gets like flat. Is that clear? Madara, is that clear to you? Huh? Sort of. Where was it like not very clear? The A to B and C to D E to F, right? So you can understand it by thinking of how what's happening to S. There are two ways of understanding. You can understand it by thinking of what's happening to S. From A to B, S is increasing. It's increasing the value is increasing. From E to F, at E you have that much of displacement, at F it is less. Displacement is decreasing. That means you have to come. Here you are going away from the starting point. That's why your displacement, the distance from the reference point is increasing. If the distance from the reference point is decreasing, you have to be moving towards it. That's one way of thinking about it. Or from the sign of the slope. Now you said here the slope is positive. Here the slope, Malik and Mihir. Maybe you can go home and do that. The slope from E to F is negative. What do you mean by negative velocities? That means velocities, here velocity is positive, here velocity is negative. What's the meaning? Positive velocity, negative velocity. What's the difference there? What does the sign tell you? The sign indicates the direction. So if I have taken this as positive, here positive velocity, I am moving that way. Here negative velocity means I am moving in the opposite direction. That's the other way of understanding it. Same type of motion, acceleration. Only difference is the direction of motion. This is accelerating in a particular direction. This is the same or whatever acceleration in the negative direction. Coming back in relation to this direction, coming back. Okay. Right. So you start drawing this. Have a little sketch like this too. So he is actually like if you were looking at this how this man is moving, he's like he has not coming back. And this point is, and he stops here and waits for some time. He's resting for some time, right? Some amount of time he's resting, not moving at all. At E, this is D and E are both here. Yes.
The displacement is
Decreasing.
and the velocity is negative.
Velocity is negative, very correct, yes. So I will write stuff on the graph in connection to this diagram that I am drawing here. Okay. So I've taken this as that way. So to the right. This is accelerating to the right. Now say that this acceleration. Here is accelerating. In the other direction, in the opposite direction. the main thing you have to know. So just by studying the slope, what's happening to the slope, you can explain everything. And if you need another, like I put this in a bubble, negative slope. All the way here throughout the slope is negative. So from E to H, it's all opposite direction. A to D in some direction, E to H opposite to that direction. Positive slope, negative slope. Remember, we are studying only the motion in a straight line. So only two directions you can have, going forward or backward. In one direction along the straight line, in the opposite direction along the same straight line. So those two directions are indicated with plus and minus. So the sign of the slope tells you the direction of motion. So notice here that from A to, all the way from A to B, positive V. E to H, negative V. Same, according to my diagram, moving to the right, just moving to the left.
Stationary.
Yeah. This is the most important thing, velocity equals radius. To the negative side. Yeah. What would that mean? If this but then it goes to the negative side of the displacement axis, so negative displacement. What would that mean physically? What's happening in the diagram? What's happening?
Going past the point it started.
He's going past the starting point in the other direction. So displacement, you started to measure it from here, this way as positive, now that way is negative displacement. Okay? Isn't it wrong now? Huh? No?
No, it's okay.
I should sit here somewhere. There it's wrong. It doesn't come to that side. I should change it. Is it forward, you guys? Is it forward? Come on.
If they ask like question, what happened to distance?
Okay, so if you are given this graph and they ask calculate the total, would not be calculated. If they ask what is the total distance traveled, now let me put some values here. If I give you this, the value right at the top here, if I give you that 100 or something, give you meters. Okay, if I now ask you what is the total distance traveled, by this person, 200 meters, right? 100 that way. 100 coming back. What's his displacement? What's his displacement? 0. He's come back to the first point. Even somewhere in the straight line, he came back to the same point. He came back to the same point. He has come back to the same point. Your graph ends here. S0 here, S0 there. Good questions. But any more questions like this? If I give you enough information, I give you these 2 points. Like say this is 20 and this is 70, and if I give you these time values, you can compute the velocity here by computing the slope, gradient, y difference over x difference. That's the only thing you can calculate. Other things you can look at the graph and say, distance travel, you can just look at the graph and say, displacement, you can just look at the graph and say. If I ask you what is your velocity from this point, from B to C, you have to calculate it. Can I ask you to find what's the acceleration from A to B? I can't ask you to do that, you can't find it from the graph. So the things you can find and calculate from a displacement time graph are distance travel, displacement time. If there are straight sections, that velocity you can find if the information are given. Can I put some values and give you some questions here? So 127 where can I write here? Find the total distance travel. The total displacement. Total means for the whole journey, the final displacement. Velocity from B to C.
Questions when they ask us to use differentiation or is there the average slope to gauge about?
But that would be something that, no, I mean, from the graph, you can't do any differentiation, but you do have that in one section in mechanics. If I give you, now here the displacement is changing in a certain manner with time. If I give you that function, you can differentiate it twice to find acceleration. If you differentiate displacement once, you get velocity. If you differentiate velocity one more time, you get, because rate of change of displacement is velocity, rate of change of velocity is acceleration. So if I give you displacement like a function, as a function of time, an expression of t like 2t squared plus 3t or something like that, you can differentiate it twice to get the acceleration. Or if you differentiate it once, you get the velocity in terms of t. By plugging in different values of t, you can find the velocity at different points in time. And you do that, you have that in mechanics later. From the graph, there's nothing you can do. So these three are the only three things you can find from a displacement time graph. Displacement, distance and velocity. Velocity also, if it is traveling at a constant velocity, you can find it. If I ask what's the velocity right at this point, you can't find that. I mean, graphically you can draw a tangent and do that would be not an accurate. Roughly you can just do it. By computing you can't. There is no like computing method to do that. Done copying? I didn't do the question. So those who did, what was the total distance as we discussed? It's 200. Total displacement from beginning to end 0. Velocity 10. So you are finding the gradient from B to C by difference of its difference. Yes. So on the only computation is here, velocity. There is nothing to compute here. You just write the answer. This is 200 meters. You write it. This is 0 meters. Velocity you compute, you say gradient. You can say velocity equals gradient. So you write this. And then you calculate the gradient. 70 minus 20 divided by 15 minus 10 is meters per second, 10 meters per second. Little small computation.
So, time.
Yeah, we have to stop.
Time.
Time's up. Time's up. I want to give it 9 minutes, almost 30. 1 minute.